Hey everybody, welcome to our lesson video for 7.8b. In this video, we're going to be just recapping a couple of our factoring techniques that we talked about in 7.8a for factoring higher degree polynomials, and then looking again at just that last step of how you actually solve them by setting, when they're equations, when you set them equal to 0, and then use the zero product property to find your solutions or your x-intercepts. So if you'd like to, you could continue your note sheet from 7.8a, or you could set up a new one with the section, the date, and the I can statement. And then as soon as you're ready, resume the video. All right, so just to recap here, let's look at a couple factoring techniques for higher degree polynomials. So for the first one here, we have 3x cubed plus 6x squared minus 24x. And this looks hard until you factor out the GCF. So that's always going to be our first step. In this case, the GCF, the thing that all three of these have in common, is a 3 as well as an x. So our GCF would be 3x. So we would factor out 3x, and then inside we would have x squared plus 2x minus 8. And so at this point, the cool thing here is that x squared happens to have an a value of 1. So for this one, we can just use the sum and product technique for factoring, which is pretty exciting because it's easier than box and diamond or the split method. So our sum would be 2, and our product would be negative 8. So we need two numbers that multiply to negative 8 and add to 2, which is 4 and negative 2. So if we factor, we would have 3x times x plus 4 times x minus 2. So you can see here that essentially what we're doing is we're using our techniques that we learned like earlier on this chapter, and we're just adding in another layer of factoring out the GCF first. So another example of this, 7x to the fourth minus 28x squared. These two have a GCF of 7x squared. So if we factor that out to the front, 7x squared multiplied by x squared minus 4, now we see that difference of perfect squares again, where a equals x and b equals 2, and we have a minus sign in the middle. So we can factor that into a plus b times a minus b. So we'd have 7x squared multiplied by x plus 2 times x minus 2. So again, it's kind of cool because once we pull that GCF out, then we're just using techniques that we learned earlier on this chapter. Really the only new technique we learned in this section was the factoring by grouping technique. So the last step here is just to build in solving, where it's actually an equation. And it's really no different, except the first thing we want to do is we want to set it equal to 0, just like we always do, because we're trying to find x-intercepts where y equals 0. So I'm going to subtract 10x and get 2x cubed plus 8x squared minus 10x equals 0. Now we're going to find that GCF. And in this case, these three terms, they have in common a 2 and an x. So we can factor out 2x here. And if we factor out 2x, we're left with x squared plus 4x minus 5. And that's actually pretty convenient because we can do our sum and product again, where our sum, adding them together is 4, and our product is negative 5. So we need two numbers that add to 4 but multiply to negative 5. So negative 5, some of those multiples are like basically just 5 and negative 1, or negative 5 and 1. And in this case, to add to 4, it would have to be 5 and negative 1. So we've got 2x times x plus 5 times x minus 1 equals 0. So now we can just use our zero product property. So 2x equals 0 means that x equals 0. X plus 5 is going to get to x equals negative 5. and x minus 1 equals 0 tells us that x equals 1. One thing I want to point out here, you might notice that we have 3 solutions and we have a degree of 3 up at the top. That's not a coincidence. Just like with quadratics, we'll always have 2 solutions. With cubic functions, we're always going to have 3 solutions. With quartic or 4th degree functions, we would always have 4 solutions. Now, you might be saying, wait a minute, some of those quadratics, I thought we only had 1 answer. And that is sort of true, because sometimes when we did the quadratics, we had the same factor twice. And so that was the same solution repeating 2 times. And you could have the same thing with a cubic. You could end up with 2 solutions where one of them is just a repeat solution. That is possible. So the key, though, is what I always think about is I look for those 3 solutions, even if one of them happens to be a duplicate. So this is how we're going to actually solve higher degree polynomials. We're basically just going to set it equal to 0 and then find the GCF, or use factoring by grouping, and then just factor and use the zero product property, come up with our answers. So that brings us to the end of our short video for 7.8b. Try the homework and let me know if you have questions.